Thank you, Professor Sato and Professor Wu Ying. Good morning and good evening, everyone. I'm Ying Jie from East China Normal University. It's very great pleasure indeed for me to have the opportunity to speak at this meeting. Today, I would like to give a talk about modeling and emergency response in host cities.
G?
Yeah.
Could you camera on? Your camera on?
Oh, camera. Oh, sorry.
Okay.
Oh, okay.
And then, yes, share screen again, please.
Okay. Okay.
Yeah, perfect. Please.
Sorry. Whoa, what's wrong? Okay. Yeah.
Wait, please.
Yeah. Okay.
Start with the code.
Yeah. Flooding is among the most frequent and devastating natural hazards, resulting significant casualties, losses, and impact in many coast low-lying areas around the world.
Yeah.
What's wrong?
You are now. We are looking at your presenter mode screen.
Oh.
And yeah, maybe could you full screen? Yeah, try again. And here.
Okay.
At first, share your PPT and then full screen presentation. Yeah, it's fine. Yeah. Now we are looking at the full screen. Yes.
Okay. Yeah. Coast cities are particularly vulnerable to flooding given their highly developed economy and high density population. And flood disasters significantly increased over the past century. And the risks are expected to evolve due to climate change and rapid urbanization. Yeah, due to the specific location, coast cities generally are subject to flooding from various sources. Storm surge, high tide, heavy rainfall, and upstream river flooding are the four major drivers of extreme flood levels in coast cities. Compound flooding tend to be triggered when 3 or 4 of these drivers occurs at the same time. Indeed, in addition, some climatic and non-climatic factors such as sea level rise, land subsidence, storm intensification, and coastal erosion further exacerbate flood hazards in coast cities. So we developed a GIS Rust-based flood inundation model, ECNU Flood Urban, which can incorporate both major hydrologic processes such as infiltration, evaporation, and the soil system model, and 1D, 2D coupled hydrodynamic models. Thus, it can be used for fluvial, coast, and compound flood modeling in coast cities. Okay, we perform both city scale and street level modeling of Hurricane Sandy induced flood inundation obtained by some problems. Okay, we perform coast flood modeling and coupled with ASIC storm surge model, and the storm surge model result as input to the to drive the flood inundation model. We use Hurricane Sandy in New York City as a case study. The Sandy-induced flooding inundated the low-lying areas of in Lower Manhattan, New York City. Okay, we also performed both city scale and street level modeling of the sandy-induced flooding in addition, obtained by ASIC and coupled simulations. Model outputs were compared against observed flood level and in addition extent provided by FEMA. The simulation suggested an improved performance by coupled modeling over ASIC modeling alone, with RMSE increasing from 0.5 meter to 0.26 meter at city scale and the 0.29 meter to 0.1 meter at street level. This is likely due to the finer grid resolution used by coupled modeling. Okay. We further We further developed the interdisciplinary approach approach that covers hurricane model, storm surge model, inundation model, dike reliability analysis, and the sea level rise projections to estimate tropical cyclone-induced post-flood inundation hazard in the post-Met city, Shanghai, China. We know Shanghai has witnessed frequent extreme flooding induced by tropical cyclones due to its location within the Northwest Pacific Basin and its low-lying topography. The annual maximum water levels were generally caused by the high tide and the storm surge. In response to rising record water levels, a flood defense system, namely flood wall along Huangpu River and sea walls along the coast, was initiated in 1950s and has been reinforced several times since then. Each update of protection standard of the defense system is triggered by an extreme TC flood events, such as typhoon in 1962, 1974, 1981, and 1997, which heavily flooded the city. At present, Shanghai is protected by 408 kilometers long high-level flood walls and over 500 kilometers long high-standard sea walls. To overcome the limitation of the historical date, we estimate TC-induced coast flood hazard based on large numbers of synthetic storms. We apply a synthetic TC dataset generated by the TC model of Kerry Manual. The dataset includes over 5,000 synthetic storms near Shanghai, with time series of the storm parameters such as time, center position, maximum wind speed, pressure, and the radius of maximum wind. That's required for storm tide modeling. And the previous study found that the estimated wind hazard based on the synthetic data compared well with historical wind observations in Shanghai region. So we then generated a computational mesh and used ASIC to simulate storm tide for each case. Okay, we evaluated the model performance in simulating the.
Yeah.
Sorry.
Yeah. It's again.
G, your mic is now mute, please. Oh, yes.
Okay. Yeah, we evaluated the model performance in simulating the storm tides during historical events, Typhoon Winnie. The comparison indicated that the simulated storm tide in terms of both stage and timing mostly agree with observations, suggesting that the ASIC model satisfactorily captures the dominant dynamics of storm tide along the Shanghai coast. And then,
G?
yeah.
Could you use pointer mode? Pointer? If you point out finger,
What?
a pointer, do you cursor? You point finger by the cursor. If you change the cursor to pointer mode, I can, but if it is not possible, it's okay. I'm sorry. Yeah.
Okay.
Okay.
Well, sorry. And then statistic analysis is performed on the generated storm tide, and the probability of storm tide events was estimated by the GPD. The figures show the flood return period curves at select gauge stations and the flood levels with various return periods, 10, 100, and 1,000 years return period along the Shanghai coast. Yeah. The left figure shows the distribution, crest levels, and cross sections of flood defense system in Shanghai, namely flood wall along Pump River and the seawall along the coast. Wave overtopping is the main failure mechanism for potential sea dike breaching in Shanghai. We calculated the actual overtopping rate through an empirical overtopping function for sea dikes recommended by Chinese guidelines of sea dike design. We determined the location and the width of seawall breach along the coast of Shanghai using a recommended value for overtopping threshold, namely 20 liter per meter per second. In terms of flood wall, structural failure is generally due to water pressure under the load of high water level. The collapse of flood wall can be determined by a limit state function. This function. Okay, we generated the relative sea level rise projections under 3 pathways through the 21st century for Shanghai by incorporating the climatic components and the local contributing factors such as land subsidence. The projections show a significant high rise and a substantial wide range of uncertainty in the local sea level. A previous study found that sea walls along Shanghai was rapidly sinking. So we applied an IMBeR-based geotechnical model to predict the cumulative deformation of the seawall over a time period from the baseline to the end of the consolidation phase. The right figures show the dike failure and flood inundation under present and the future scenario in Shanghai. We found that flood inundation is likely to occur in low-lying and poorly protected area of the city, even under the present-day sea level. However, without adaptation measures, the risks increase by a factor of 3 to 160 across the densely populated flatland under the project sea level rise to the end of this century. Okay, over the recent decades, pluvial flooding is attracting a growing public concern due to rising intense precipitation and increasing consequence. In order to validate and test the predictive skill of the model and fully understand the reliability of multiple source rainfall data in pluvial flood modeling, we carry out simulations and validation using rainfall data derived from radar reflectivity and weather station record. We found that the rainfall intensity reflected by radar is significantly lower than the observations. And compared with flood incidents reported by public, it can be found that the model is able to capture the general patterns of inundation areas at the city scale. The advantage of the model is further illustrated in the subregional modeling using a higher resolution DM with 2 meters. The model is able to capture the details of the flat area and flat depths at street level. The right figure shows a comparison of the observed and modeled water depths, suggesting that spatial temporal accuracy of the rainfall inputs and the micro topography are the 2 critical factors that affect the final estimates of flood simulation. Okay, we are highlighting our flood model developments in real-time high-resolution surface water flood nowcasting system in Shanghai to support operational emergency response. First, the real-time rainfall data is provided by the partner Shanghai Met Office and will be received and stored every hour through an API in our data server. Second, our model will perform high-resolution flood numerical simulation through parallel computing in the model server. Finally, flood inundation mapping will be undertaken and exported every hour through GPU by map server. Okay, this is a real-time flood modeling system in Shanghai. It can provide 50-meter resolution city-scale flood modeling output and assess potential flood impacts to support the decision-making of emergency responders. Okay, flooding resulted in not only considerable direct losses, but also increasing in indirect impacts, particularly in transportation sector. We make use of high-resolution 2D inundation modeling and adjust network analysis to evaluate the potential impact of fluvial flooding on traffic network in the city center of Shanghai. Results show that there is a nonlinear relationship between increasing fluvial flooding and the indirect responses of widespread transportation disruptions. Emergency responders must reach urgent cases within required time frames, regardless of weather conditions. Flooding can impact the performance by making roads impassable or increasing traffic congestions. We evaluated the cascading impact of coastal flooding on traffic disruption and emergency response in Lower Manhattan, New York City. And the results suggest that coastal flooding causes significant decreases in emergency service coverage and dramatic increases in response time. The performance of the operational response is largely determined by the positioning of emergency facilities and the functioning of traffic network. We also investigated how various levels of flooding impact the ability of emergency response to vulnerable populations in England. An important finding is that flooding reduces the spatial coverage of all population subgroups dramatically, but the elderly people always had the least cover. The finding highlights the importance of addressing the geography of inequality in emergency planning, and the results provide opportunity to identify hotspots of vulnerability, such as care home, sheltered accommodation, nursery, and schools, for optimizing the distribution of response stations and developing contingency plans for strategic sites. Okay, that's all my presentation. Thank you very much.
Thank you, Ji. Very great talk
Hi.
about the contribution of science to societal problem. So any question, comments to his talk, presentation?
May I?
Oh, yes, In, please.
Yeah. Professor Yin, a very interesting topic. I think you did quite successful coastal flooding models. Could you just share what's the big challenge and how to make your achievement about such kind of modeling works?
Not clear in my side.
Can
you pardon?
Curious, what's the big challenge to such kind of a coastal flooding model works? And so what's your experience and knowledge you would love to share with the audience?
Okay. Sorry. Let me share the screen. Can you see my PPT?
Yep.
Yeah. Okay. I think the big challenge is climate change, and sea level rise is rapid rise in this century, and maybe and particularly in the coast cities, such as particularly in delta cities, land subsidence at some rise in this background. And in Shanghai, the land subsidence is very, very serious. So I think this is a big challenge in the future to exacerbate the flood hazard and the flood risk in the future. So I think the flood risk assessment is very vital for the sustainability in the future for all coast cities along the coast. Okay.
Thank you.
Yeah.
Okay. Thank you very much.